Hi, Chris Kuzmo here. We're going to do a little bit of function analysis. And how we're going to do this is we're going to start real basic. I create a slider here, a variable, which is going to correspond to the intercept for a line. Okay, and right now that value is set to 0.2. And I come up with a slope for the line, and that value is currently set to 0.5. What's the line look like? Well, there it is. It's intercepting 0.2, and its slope is 0.5. You can see this illustrated if I vary the slope or if I vary the intercept. You can see that the point of the intercept varies, the slope varies. Not surprising. That's algebra 1. No problem. Let's suppose we introduce another intercept. We'll call that intercept 2. Another slope. We'll call that slope 2. And so there's a corresponding function to that, which we call g of x. So now we have two lines, the purple line and the red line. And we can, of course, also vary the slope for the purple line, which again, we're calling g, vary the intercept for it. So we have these two lines. And there's starts to be some interesting points about these two lines. And that's basically intersections. Where the red line crosses the x-axis is what we call a zero of the red line of the function f. The zero of the function g is also interesting. And it's going to turn out to be the case that the intersection of the two lines themselves is interesting. So the way that it gets interesting is when we multiply the two functions f and g together. We multiply those two functions together, we get a parabola. And the point where either one of the functions out of which g is created, out of which p is f of x times g of x. So this brown line, which is named p, is the product of the purple line and the red line. And its maximum corresponds to the intersection of those two lines. And its zeros corresponds to the zeros of the two lines. This is approaching the central concept, the most powerful ideas in Algebra 2. Okay, and we have to be comfortable with these before we start to talk about calculus, okay? So when we start to talk about calculus, it's like, well, how do we determine this point? If we are not given g and we are not given f, it turns out that we can use some tricks in Algebra 2 to find out where this maximum point is. But those tricks start to peter out if we add a third function. So h is another line, all right? And I'll hide it for now, but I'm going to multiply f and g and h all together. And now we have another line, it's like another curve. Now it's getting very interesting. And this function has three crossing points, and we're going to get rid of p, and we're just going to look at q. So here we have q, and q now has some interesting points. It crosses 0 here and here and here. What are those? How do we determine those 3 points? It has a maximum somewhere in this vicinity, and a minimum somewhere in this vicinity, but it also goes way up to the left and goes way down to the right. Those are all characteristics that we would like to be able to infer from just having only the formula for q, not necessarily knowing about f and g and h, out of which it is built. And so the process of function analysis is to tease those things out. And our tools for doing that are factoring or finding the zeros of polynomials, which is Algebra 2, and only works and it's only easy to do for quadratic equations. Anything higher, like a cubic or higher, it's difficult or even impossible to use Algebra 2 techniques to find these maximums and minimums and zero crossings. And so to find those, we need to be able to use calculus techniques. And one calculus technique is taking the derivative of the function. If we take the derivative of the function, then suddenly the characteristics of the derivative will match some of these interesting characteristics of the original function. And we'll get into those things in future videos.